Hello and welcome to this presentation of ANSA and Metaphor CFD version 23. In this presentation, we will focus on the latest developments of ANSA and Metaphor CFD applications. Let's start with interface. When the user starts ANSA, the launcher pops up and they can select among different predefined layouts. Up to now, the CFD layout was recommended, but now in version 23, we have added a new layout called Aerospace. This new layout is targeted to aerospace CFD applications with quad-dominant surface meshing, anisotropic leading and trailing edge treatment, low Reynolds layer settings, tau quality criteria, and tau solver. A new function has been added in the GUI. It's like virtual post-it notes. The user can create their own notes of tasks that they have to do in the file so that they are reminded when they open the file. Moving on to functionality about extracting the wetted area of the domain. The old function isolate exterior has been replaced now with a new isolate visibility groups function. And this is used to very quickly identify what's exterior and interior in a complicated geometry. The basic settings of this function is first of all to select scan all around or normal to screen. This means that ANSA will identify what is visible all around the model or at a specific view angle of the model. Basically, you can imagine this function as a set of cameras seeing the model from all around, and they can detect what is visible or not based on a percentage of the number of cameras that can see the specific entity. Also, identification can be done at entity level, like a specific face or shell element, or PID level, complete PIDs. Some advanced parameters. The user can also predefine some sets of entities that are internal or external, as they are already known, and also merge options. Specific small groups of areas can be merged into neighboring larger ones if the neighboring areas are visible and these are not. So when the user executes this function, ANSA sees the model from various view angles, and then every entity is marked according to the percentage of cameras that sees the specific entity. In this way, some entities are marked as absolutely exterior and some as absolutely interior, if they cannot be seen by any camera. Of course, there are some intermediate positions where some entities are seen by few cameras. Based on this list, the user can select some of these groups and isolate it on the screen, or hide it, or set these entities into a new part, a new PID or a new set. And this helps a lot the identification of the important geometries of the model. This is very useful. For example, before going to surface wrapping, the user can remove some unneeded entities so as to make the wrapping faster. Moving on to surface meshing. The function mesh generation four-sided has been enhanced with some new options, specifically when quad element type is used and the number of nodes is not aligned so as to give a pure map mesh. The user can select where to position the transition pattern of quad elements. Also, a new option has been added for perimeter spacing so that ANSA will automatically align all perimeters so as to create a pure map mesh, if this is possible, of course. Moving to the function shell mesh fill gaps, which is the function that is used to automatically close narrow gaps, usually in imported STL meshes. A new option has been added to ignore gaps in the same PID, so that the function is focused only on gaps between different panels. Moving on to size field enhancements, a new size rule has been added in ANSA. It's called surface section. The user specifies on which surface PIDs this will be applied. They specify a direction along which this will run, and minimum and maximum dimensions and imposed lengths at the two ends. In this way, for example, the user can specify a direction along a wing, the start point and the end point, and the maximum length at the two ends. In fact, this can be input manually by the user, or they can use the automatic calculation properties. ANSA will automatically identify the start and end points and also will calculate the start and end lengths based on a percentage of the local chord, as ANSA will also calculate the chord at the root and at the tip of the section. This function yields a very nice result where the maximum length varies linearly across the span of the wing in a very smooth way. Linear size variations has also been implemented in other size rules like the surface offset and the cylinder size rules, so that the user can impose a linear variation in the direction of the growth and not only a geometric growth as it was before. Moving on to surface wrapping, the Octree wrap entity has been enhanced with a new category here, quality criteria. So similarly to batch mesh, for standard meshing, the user can specify the CFD, the meshing parameters, and also the quality criteria. In order for this quality criteria to be respected, the default improve wrap mesh methodology is now set into advanced, so that ANSA considers the quality criteria and ensures that there are no violations. A new option again in Octree wrap is the merge property if element number is below a certain value. If, for example, a small feature with a different PID is resolved with a very small number of elements, ANSA will automatically merge this PID into the neighboring PID. Also now in ANSA it is possible to interrupt the surface wrapping process by pressing the escape button if the user decides to stop the running of the process. Moving on to checks. After batch mesh, there are several areas where, due to perimeter joining, macro areas become very large and some perimeters are not closed. This check can identify these areas and provide the option with right-click fix so that the perimeters are closed and the macros are separated. Another check is the surface mesh FE cracks and gaps. It can identify small gaps in FE model mesh, and again it provides the right-click option fix so as to stitch this gap. Moving on to the Octree leak tool. New enhancements here. First of all, ANSA provides 3 levels of accuracy. This is of course a trade-off between speed and accuracy of leak detection. And a new option not only to close the leaks, the identified leaks, but also to create interior wrap surface meshes so that they block any leaks that may be left over. And again, this is a nice preparation for surface wrapping, the creation of inner wraps that block any remaining leaks. A major redesign has taken place in version 23 with respect to the mesh parameter window, both in the standard meshing, the manual meshing, and in batch mesh as well. We have made some changes so as to make the interface more compact. In fact, the user should only be concerned with 2 tabs of this window, the basic and the features. The basic feature has been redesigned so that first of all you specify, of course, the mesh type, CFD mesh and mixed or tria, and then the user specifies the growth rate for CFD and the maximum length. Then they specify for curvature refinement the distortion angle and the minimum length that ANSA will drop to refine this curvature. Then they can specify proximity refinement parameters, and then they can specify the level of simplification of perimeters, how many perimeters will be automatically joined, and when ANSA should join a perimeter, if the gap is smaller than the local element length, for example. And then the user specifies the initialization process. What happens to the existing mesh? Is it kept or erased? What happens to the features that have been identified? Are they cleared or are they respected? the orientation of the mesh, is it fixed or is it automatically calculated, and what happens to already joined perimeters. So the user should specify this, and of course the feature treatment in the second tab, which is the same as before. We have made enhancements in the speed of batch meshing for mixed type mesh, so now it's twice as fast as before. And we have added a new option called draft result, and this allows a quicker preview of the resulting mesh for the user so that they know that their settings are suitable. Of course, it excludes some additional improvement steps. That's why you may see some abrupt changes in the length here, which are of course fixed if the full process is run. So draft result is available for mixed type mesh so that the user can have a quicker preview of the result and check that the settings that they have put are the ones that they want. And this results to even a greater speed up. For anisotropic leading edge treatment, we have improvements. First of all, the option has been renamed to anisotropic. In the past it was called gradual. And now a new calculation method of the first height has been added based on the local distortion angle. This allows the variation of the first height of the anisotropic mesh based on the local curvature. For example, on a wing where the local curvature changes with a chord, ANSA will automatically adjust the first height so that the distortion angle is respected. A minimum first height is also specified by the user to avoid excessive over-refinements. New option to enable the specification of constant rows of anisotropic mesh starting from the leading edge, 2, 4 or whatever the user wants, and then growth rate starts. And the maximum zones number is now an option. The user doesn't have to specify the number, they can leave it blank. And ANSA will stop growing automatically the zones whenever the maximum aspect is reached. Another enhancement in anisotropic mesh is usually when ANSA generates an isotropic mesh, at the ends of the features, the length drops to isotropic. Specifically, however, for areas where a wing connects to a symmetry type boundary condition, like a flat symmetry plane, for these cases only, ANSA will not drop to isotropic mesh, but the anisotropy will go all the way to the symmetry plane, both in leading and trailing edges. For this to take place, the user must specify the specific PID of type symmetry. The automatic calculation of the first height based on local curvature may not always give user desired results if the quality of the surface is not of high quality. For these cases, the user can impose a first height at specific locations so that ANSA respects these inputs and varies the height linearly between them. For the user to specify these point sources, let's say, there is a user script function called create leading edge point sources, where the user can pick locations and specify the first height. Once this is set up, then batch mesh will consider these point sources and automatically adjust the first height in a linear variation between them. There have been enhancements in batch mesh with respect to how it treats boundaries between FE model mesh and geometry. In the past, the connectivity could be broken, but now ANSA always respects the connectivity, whether you remesh both FE and geometry together or part of it. The connectivity will always be maintained. It can be altered with respect to the distribution of nodes, but connectivity will always be ensured. Moving on to volume meshing. Hexa Interior now has a new option It's called Connect to Symmetry. And this will allow the hexes to connect right to the symmetry plane and avoid a buffer zone of pyramids and tetras. For this to take place, the boundary condition on the symmetry plane must of course be type symmetry, and it must lie on the XZ plane. By enabling this option, Hexa Interior will connect on it with pure hexes. Another major new development in version 23 is the addition of thin wall meshing. This has been added in the interface of layers. So there's a new option that the user can enable here, thin area treatment. They only need to specify what is considered as a thin area. They can specify maximum thickness, either an absolute value or a percentage of the local element length. And then they specify the number of layers that should pass through the thin gap. There are two modes. One is the constant number of layers. This is usually recommended for solid components, where you mesh with constant height layers. For flow domain, this can be specified as a minimum number of layers, so that the boundary layer is resolved very well through the thin gaps without the generation of tetra elements in between. For batch mesh setup, there's a new option in layer areas where the user can specify the direction on which the layer should grow. So the default, of course, is gray, the positive side, but they can change this if they want. And of course, there's the option both, which is the default old option of zero thickness walls, so where layers grow from both sides. Another new option in the fixed quality tab is the option constrain layer nodes. This has to deal with how ANSA treats thin layers for fixed quality. If the aspect is high, ANSA will only move the nodes along the height so as to not disrupt the normal vector of the layers. If you deactivate this option, then ANSA will be allowed to move the nodes away from the normal direction. It gives more degrees of freedom, it may fix more elements, but it may also violate the normal vector of the layers. The default option is on, so that the high aspect layers maintain their orthogonality. For quality criteria, we have added support for tau negative volume calculation, both total and partial, for negative volume and for minimum volume as well. The off inspector, which is the best tool to inspect the quality of a volume mesh, has been enhanced by reporting here at the bottom the total number of off elements and also the worst quality for every category. Moving on to extreme meshing, there's been a lot of improvement with respect of capturing zero thickness walls, baffle areas. In the past, this was not so well maintained. Now, the detection and capturing of zero thickness walls is more accurate. Moving on to hexablock meshing, we now support 2D structured meshing with 2D boxes and the generation of O-grids on 2D boxes. So similarly to creation of O-grids for 3D boxes, now this can be done for 2D. And now the 2D mesh that is created on 2D boxes can be output in structured format, both in CGNS and Plot3D formats. For smoothing of hexablock meshing, we now support periodic models, so we can smooth periodic meshes without violating periodicity. And we support second-order meshes for smoothing as well. The function split, boxes split, has been enhanced by including more functionality in one function. The split edges is where the user splits a box along an edge, but the option split faces allows the splitting of a box along a face. The user can say, if the user selects a quad face, Then they have two options to split either between two corner nodes or a corner node and an edge and create such a pattern, like that here. And if the user selects a triangular face, ANSA will split it into three hexa boxes, right? So you go back to hexa box. Another new function is the box's new tubular. The user can select a geometry of pipes. Then they can select the start and end. And ANSA will automatically create the structured hexa boxes that will follow this geometry. So this is used to quickly create hexablock boxes for cylindrical geometries, for pipes. Moving on to morphing. Now, a big improvement here. Morphing boxes can be used to directly morph geometry as if it were FE model mesh. In the past, this was not possible in ANSA. The geometry had to be split at the boundaries of the boxes, and that was a complicated process. Now it's very easy to do. You simply deform the geometry with the boxes as if it were FE. The function direct morphing form has been enhanced. The GUI has been changed slightly. Now the user can select, first of all, how to set up the handlers. The handlers are a set of coordinate systems along the axis that the deformation will take place, the bending, the twisting, and everything. So in handler setup mode, the user can modify the position of the handlers, the neutral axis and the end points. And then if they switch to free ends, they can start to deform the geometry either to bend or twist or extend it. So two modes of functionality. One is the setup to align the axis, and one is the actual deformation, either the free ends or have pinned ends and move the neutral axis in the middle. Moving on to support of CFD solvers. We now support native I/O for Kestrel CFD solver via the AVM mesh files. We also support the setup of the boundary conditions and setup of the case for the solver Flow360 through a new user script button called Flow360 Setup. This provides a wizard where the user can specify the boundary conditions and the basic solution setup. Enhancements in output for CGNS and Fluent. The window of CGNS output has been redesigned so that it has all the options here. The file type, the library version, the mesh format, and also advanced options for specific options that CGNS has. This allows the compatibility of our CGNS output with almost all CFD solvers. Also, there is an option to write the definition of unmeshed volumes. So even without the volume mesh, the CGNS file can contain the information of the volumes. Similarly, for Fluent output, the user can have an ANSA mesh, a mesh in ANSA, and the definitions of the volumes can be output as Fluent regions in the Fluent without the volume mesh. The report tool has been enhanced with the reporting of actually the number of faces of the model. This includes all faces, exterior and interior. This is an important value because now that the models tend to increase in size to hundreds of millions and possibly a billion, this number increases a lot. And for example, if it exceeds 2 billion, it may have some problems in specific formats so that the user can know in advance if a certain format supports output of such big models. We also support output of Fluent HDF5 MSH files. And we support input-output of high-order CGNS meshes up to 4th order. Moving on to post-processing with Meta. Meta continues to add more support of different solvers. So there's a wide format of CFD solvers that is supported to read native results. Some improvements here for flow paths. There's a new option to generate flow paths in a structured manner so that they look more clear as they are generated in unstructured meshes. Moving to SPH simulations, the user now has the ability to identify a droplet, so they can pick a droplet, a coagulation of several SPH elements, and calculate the volume. Meta can now also calculate the Schlieren field from the read scalar results, and usually this is displayed in a grayscale color bar to look very similar to the typical photographies that are taken in this method. Some final improvements is the possibility to output from CFD Post toolbar the output of Fluent interpolation files so that they can be read back into Fluent and mapped on a different mesh, and the support of part manager structure from StarCCM results. And this concludes our presentation. I'd like to thank you for your interest, and we're always here to answer your questions and help you. Thank you.